Okay, so what is today's lesson's first topic? Well, maybe we should do a little bit of a recap before we get going. So what happened in the last lesson for those who are who were here, and just to help out our new students, what did we do in the last lesson? Put it in the chat. What can you remember? Keisha, let's unmute you. Keisha, what do you remember from the last lesson?
Hi, sir, can you hear me?
Yeah, loud and clear.
Okay, so on the last lesson, that was on the 9th, we did central tendency.
Okay.
The range, the Q1, the Q2, the Q3, the interquartile range, and stuff like that. And we also did the standard deviation.
Perfect. So lesson 1, we did central tendency, which was the mean, the mode, and the median. And then the last lesson, we did something called measures of dispersion, or how spread out something is. And we spoke about Q1, Q2, Q3. And we also spoke about the interquartile range, which Q3 minus Q1. And we also spoke about something called the standard deviation. So in the last lesson, it was more around this. In the very first lesson, it was about central tendency, which was the mean, the mode, and the median. Okay, and we also spoke, quite right, Eliche, we also spoke about something called the semi-interquartile range. And the main idea was, the first lesson was about where the middle of the data is, and the second lesson was about how spread out the data is, and what can we measure to tell how spread out the data. Give me a thumbs up if that sounds vaguely familiar to you, and give me a thumbs down. Maybe some of our new students have never seen this stuff. Give me a thumbs down if you feel like you've never, that looks unfamiliar to you. Okay. Now, one of the other things that was important in the last lesson was, if you were finding Q1 or Q2 or Q3, you had to first use what's called a position formula. And the position of Q1, the position of Q2, the position of Q3 helped you know where in a list of data the quartiles were. And the formulas we used for the position were the following. And so what I want to know from you is, what does the N stand for in these position formulas? So what does the N stand for in these position formulas, which help you get the first, second, and third quartiles? Who can tell me what that N stands for? Yes, Annie, let's go to you. What do you think the N stands for in those formulas?
Sir, it stands for the number of digits within the given.
The number of items. The number of items, yes, in the list. Perfect. Perfect. Perfect.
I wanted to ask something, sir.
Yeah.
Sir, isn't the quartile 2.5 n plus 1?
Okay, good question. So it turns out that you can use a half, or you can use 2/4, because they mean the same thing. So both are correct. Yeah. Okay, lovely question though. Cool. Okay, now what I want to do today is I want to introduce something called a percentile, which is very similar to a quartile, except it's just slightly different. So here's an example. say we rank everybody in the class from the shortest to the tallest person. Now, if we wanted to find the median, we'd go to the middle of the data. But you can also say, where is the 80th percentile? So the 80th percentile. And the 80th percentile's shorthand name is P80. And what P80 is, and the drawing is showing you this, P80 is here. And what that means is that 20% of the people are above. So 20% of the people are above P80 and 80% are below. So this is 80% of the way through the data. Now, how do we find the 80th percentile? Now, all we do is we use a very similar formula. So first of all, we go position P80 is just going to be 80 over 100 times n plus 1. Then once we find the position, we can then go and find the value in the list. So it's very, very similar to how we find quartiles, except that we use the number of the percentile as the numerator. The other thing that's a little bit different with percentiles is if we fall between two values, we don't average them out. So with quartiles, we average out between the two values. With percentiles, we simply go to the nearest value. So what I want to do together is I want to do an example of finding the percentile or the 80th percentile in a list of data. So here is a list of data that has been ranked from smallest to biggest. And I want you to find me the 80th percentile or P80. Now, in order to do that, you are going to first have to find its position using this formula. Find me the position of P80 and put it in the chat. So find me the position of P80 and put it in the chat. So what do we get if we need to know how many items there are. 2, 3, 4, 5, 6. So there's 22 items, it looks like to me. And so we go 80 over 100, 22 plus 1. And this is the position of P80. What value are we getting in the chat? Well, what I'm seeing from lots of students is 18.4 as the position, but that's a problem because 18.4 is not an exact position. And now instead of going, so for example, 18.4, if this is 11th position, that's 12, 13, 14, 15, 16, 17, 18, 19. Now, we're not going to average off. We're just going to go to the nearest position. And what's the nearest position for P80? It's going to be the 18th position. Now, that is a little bit different to what we did before, where we averaged them out. So let's go and find the 18th position. If we start at the beginning, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11. And then we're going to go 12, 13, 14, 15, 16, 17, 18. The value of P80 is 27. And in this case, it actually didn't make a difference. But basically, if you get to 27, 20% of the data is above, and then 80% is below. Now, that was just the basic idea of a percentile. I want to give you another question to see if you've really understood it. So if I say to you, find me the 65th percentile, find me P65. I want you to work out what the 65th percentile is for this data set. And while you're doing that, I would encourage you to ask, Annie's asked, what if it's 18.5? Then you would round up, Annie. You would round up to 19. Yeah, the 19th position. Who has a question while other students are working on that? So before I can get what P65 is, I first have to find the position of P65. Where is it in the list? So I go, the position of P65 is going to be 65 over 100 times n plus 1. And this was 22. So what am I getting for my position of P65? What's my position going to be? Is there a decimal value for this one? So 14.95, 14.96, 14.95. Okay, now if we round this off, it's going to round off to the 15th position, because the 15th position is the closest position. So now we're going to count. If this is 11, then it's 12, 13, 14, 15. And so the 15th position is there. And so the value of this is going to be 25. And so this would be P65. And this one over here was P80. Okay, last question. Find me P40. Find me P40 for this data set. Okay, so what's its position for P40? What's the decimal going to be? Okay, so 9.2. So that is going to round off to the 9th position. And the 9th position is going to be over here. And so the value of P40 is 20. Now, again, just to tell you what P40 stands for, P40 says 40% of the data is below P40 and 60% of the data is above P40. And so it's a way of dividing up the data. Okay. The only big difference with percentiles is the percentiles you round off for the position, whereas quartiles, you average out between the two nearest values. Okay. Give me a thumbs up if you followed that. Give me a thumbs down if you feel a bit lost. Just want to get a group feel for what's going on. Luyanda, what's your question? Oh, maybe you were just saying that you got it. And okay, fantastic. Okay, then next part of today's lesson. When we talk about a data set, so we just had a data set that I gave you that we were working with percentiles. Let me see if I can even bring this data set down. So bring that data set. Here is a data set. Sometimes we want to summarize the data set, and we use something called the 5-number summary. Okay, and the 5-number summary consists of the smallest value in the data set. So the smallest value here would be, sorry, that's the wrong place there. Smallest value is 9. All good. The biggest value would be 30. And then we have Q1, Q2, and Q3, which we worked out in the previous lesson. We showed how to do that. And what we can do is we take these values and we put them in a graph. So in the graph, what we have is a box, and the box is basically the interquartile range. It's between Q1, whatever Q1 is, and then the other part of the box goes to Q3. And then inside the box, there's a line, which is the value of Q2. And then it's called a box and whisker plot because on the right-hand side, it goes out to a whisker, and then it goes to a maximum value. And then on the left-hand side, it goes down to the minimum value. So in this case, the minimum value would have been 9, the maximum value would have been 30. But what we normally do is we actually have a number line beneath the box and whisker plot so that we don't have to write numbers onto the box and whisker plot. Okay, now I want to do an example with you, but give me a thumbs up if you've seen box and whisker plots and the 5-number summary before. Give me a thumbs down if you've never seen that type of stuff. Okay, cool. Okay, then let's do a cool 5-number summary and box and whisker plot together. So here is the situation. They do a census of a grade 10 class, and there are 26 learners in the class, and they are split into 2 groups. They are in girls and boys. The girls' height in centimeters is written here from smallest to biggest, and the boys' height is also written from smallest to biggest here. And it says, find the 5-number summary and the interquartile range for girls and for boys. So what we are going to do is I'm going to ask you, actually, you do this for me. I will do the first one as an example, but if you feel like you know what's going on, in fact, let me do the first one with you. The minimum is 150 for girls. Maximum is 170. So that was a piece of cake. And I'll just put G for girls. For Q1, I need to do the position formula of Q1, the position formula of Q2, and the position formula of Q3. But what's tricky is that N for girls is not 26. What is N going to be for the number of girls in this data set? What is N going to be? So if I look here, girls, 1, 2, 3, 4, 5, 6, 7, 8. I see the number of girls is 13. So using what we now know, the position of Q1 for girls is going to be what? It's just going to be a quarter times 13 plus 1, which is 14 times a quarter. Now, what's that position going to be? What's 14 times a quarter? Okay, so we have 3.5. Then that's the position of Q1. The position of Q2 is going to be, and let me slow down a little bit. This is going to be the 7th position. And then for this one over here, it's going to be what? What's the position of Q3 for girls going to be? Okay, 10.5. Okay, so now we know the position but we don't know the actual value of Q1, Q2, and Q3 yet. So how do we find that value of Q1 for girls? What we're going to do is I'm going to go to my set and go to the 3.5th position, which is over here. And you'll notice that it's between 153 and 155. And so what's the average value between 153 and 155? Okay, it's going to be 154. So Q1 for girls is going to be 154, and it's sitting there. What is Q2 for girls going to be? What's the actual value going to be? Or the median for girls? So I'll go 1, 2, 3, 4, 5, 6, 7. And that is going to be Q2. And so for me, I get 160. What about Q3 for girls? What do you think that's going to be? So 10.5, so I go 2, 3, 6, 10, and now 11. So I've got to go halfway between these. And because I'm doing quartiles you have to average between the two. And so Q3 should be 165. So we would say the 5-number summary for girls is going to be 150, 154, 160, 165, and then the biggest value is 170. So that is called the 5-number summary for girls. So that is the example done. But I want you now to calculate for me the 5-number summary for boys. And I want you to do this all by yourself. And I'm going to take questions from students now who feel maybe I've gone a bit fast. Those who are feeling comfortable, I want you to go ahead and find the 5-number summary for boys, and then also find the interquartile range for both of these. If you have a question, I highly encourage you to put your hand up, and we can chat some more. I've just realized that there are 13 boys and 13 girls, which makes the position calculation quite nice. Why is it so nice that I have 13 boys and 13 girls for my working out? I've got a big smile on my face now. I've just realized I don't have to do too much work here. Who can notice what I've just noticed about the position calculation? So Elikle, you've got it. The position is actually going to be the same because all the stuff that I do for the girls to find the position, it's going to be the same calculation for boys because there are 13 boys. And so I would put the same number in. The only thing that's going to be different is going to the list and looking where Q1, Q2, and Q3 is. So I don't have to do the position working out all over again because the end value I'm putting in is still 13. And the other part of the formula stays the same. Yes, Riola Bochadi. What is your question?
So my question is, sir,
Yeah,
I don't know if you can hear me.
I can hear you
You
perfectly.
can hear me? Okay. I can see that we have found quartile 1 and quartile 2, but then
Yes.
how do we go about when we reach whereby the data set is the same from like as it is here 180 until from the
Yes.
fourth until then? So how do we go about it?
Okay. So if you're talking, I think you're talking about the 10.5th position. So if I go to this list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, and Q3 falls basically between here and here.
Yes.
But the good news is that both values are the same on both sides. So what is halfway between 180? It's still going to be 180. So that is going to stay 180. So Q3 for boys is 180. Q2 is 160. And Q1 is halfway between 151 and 157. Now, because I can't just do that in my head, what I'm going to do for this is I'm going to add two values and divide by 2. So 151 plus 157 over 2. And so what do I get if I average out those two values? Who can tell me in the chat? So Elichle has said, and I agree. Let's see if anybody else agrees. Sadiq Conke agrees. So this is 154. Okay. So the 5-number summary for boys is just going to be 140, 154, 160, 180, and then the maximum value is also going to be 180. And that is a little bit confusing, I guess, but it is true. So in that way, it's got to do with there being so many values at the end there. Now, before we have a break, after the break, we are going to draw box and whisker plots. But before the break, I want to know what is the interquartile range for girls and what is the interquartile range for boys. And remember the interquartile range, remember what defines the interquartile range. So let me know in the chat what you think. For girls, I think it should just be that. And for boys, I think it should just be that. So 165 minus 154 equals IQR, which is 9 centimeters. And for boys, it seems to be 180 minus 154, which means that the interquartile range for boys is going to be 26 centimeters. Oh, did I make a mistake? Is it not 9? Is it 11? I apologize. Ladies and gentlemen, I have had a moment. And I spotted it by looking at the chat there. So girls, the interquartile range is 11 centimeters, and for boys, it is 26. Now, what's interesting about that, we're going to take a break now, so don't worry if your brain's about to switch off. That is saying that the middle 50% of girls are much closer together than the middle 50% of the boys. Or another way of saying that is the variation amongst the middle 50% of the boys is much higher than for girls. For the girls data, it's in a much narrower range. And we can see that by looking at the interquartile range. Okay, before we have a break, let's have another little vote. Thumbs up if you feel like you're following along okay. Thumbs down if you feel a bit lost. All right. Well then, ladies and gentlemen, it is time for a exercise break so that your brain, if you take care of your brain will take care of you. And so I want you to stand up with me And I want you to just start swinging your arms. I want you to take a couple of nice deep breaths. And you can spin your arms around a little bit, maybe some small circles. And then going into some big circles. And then change direction of arms, nice small circles. And nice big circles. Oh, I can feel the blood flow and the air going through my body. Fantastic. And let's do some twisting. So light rotating of the hips. Not too much at first as your body relaxes. And then as you feel nice and loose, you can start to extend the rotation. Oh, that feels good. Okay, shake out the arms again. Let's roll the shoulders. So look up ahead of you, and then while we're rolling, look away into a corner so your eyes get a break. Focus on something far away. And then change the position of your eyes to the corner closest to you. You can focus there. And then let's take some deep breaths. One more. Yeah, so hopefully some oxygen moving through the body. Let us do some heart rate raising stuff. So let's do jumping jacks. A jumping jack for our new students is just this. And we are going to do 15 jumping jacks in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, come on, 15. I love it. I see lots of students jumping up and down. That is looking awesome, awesome, awesome. And for those who were jumping up and down, let us know how you feel. For those students, we want a couple of students to feel a bit of FOMO about the jumping jack. So let us know if you feel any better having done all the brain breaks and the doing bits and pieces. Let us know in the chat how you are feeling after the break. Oh, my heart rate is jumping. I feel happy too, Annie. I'm just a bit out of breath, but otherwise, good. So while I'm catching my breath, here is the brain break for today. You have to figure out what is the number sitting in the top of the pyramid. Ooh, sure. My heart rate is up. So what pattern can we see here? What do you think the pattern is? So I was thinking 1 times, okay, 216. Okay, so the pattern is you multiply two things that are next to each other to get the thing above. So 2 times 6 is 12. 6 times 3 is 18. And so how would you get the answer for this one? You would times 12 by 18, and that would be your answer. And you are quite right. You get 216 as your answer. And it feels like today you guys were on fire. So next time I'll have to I'll have to bring a harder question to challenge you guys. Okay, let's go back to the lesson. So all I want to show you is how you draw a box and whisker lot. And I'm just going to clear some of the clutter because I feel like the page is a little bit full of rubbish. And so I want to clear the stuff. So only the essential information is left on the screen. And what I start by doing is I draw the beginning of the whisker. Well, actually, you know what we need? We need a scale. So how are we going to get a scale? Well, we're going to start at the smallest value and then go up. So let's see what I have here. If I had 140 and then I went 2, 4, 6, 8, 10, I get 150 here. 2, 4, 6, 8, 10, 160 here. 2, 3, 4, 170 there. 2, 3, wait. 2, 4, 6, 8, 10, 180. And what that is a number line below which the box and whisker plot will be drawn. And what I'm going to do now is I'm going to say, let me draw the box and whisker plot for girls first. So for girls, the smallest value is 150. And so I'm going to draw a line there. And then what I'm going to do is, where is Q1? It's at 154. So 2, 4. So there's 154. Where is Q3? That's 165. So 65. So there's 165. And that is the box between Q1 and Q3. And then Q2 is actually at 160. And then 170 was the max value, which was up here. And then we just connect these lines like that. Let me try and do that again, because that was a bit messy. So for girls, this is the box and whisker plot for girls. You have your minimum value down here, which is 150, max 170, and then 160 is the median, or Q2, and then basically the box is the interquartile range. Now, I want you to try and draw at home. I want you to draw the box and whisker plot for boys below that. So see if you can do that yourself, and then I will come along and talk about it. But I've done the box and whisker plot for girls. Maybe even doing the box first, it makes the most sense, and then doing the whiskers at the end. Different color so we get contrast. Mm-hmm. Okay, Jasmine, let's go to you. What is your question, Jasmine?
Hi, sir. I wanted to ask, since the Q3 for boys is on 180, but it's also the largest number, then what happens? Like, what do you do then?
Fantastic question. Basically, the whisker is sitting on this thing here. And so because it's sitting here, it basically looks like it's lost its whisker. But the thing is, you don't actually draw it because it's already sitting in place. So that's what you do. And so your box and whisker just looks a little bit odd. I should put 160. You're absolutely correct. So there should be a thing over there for 160, and that is Q2 over here. Okay. Thank you for that question, Annie. So I want to do another example of box and whiskers before we finish tonight, but give me a thumbs up if you followed that process. Give me a thumbs down if you felt unsure about something. Okay. The thing that you can see the thing that's really cool about Box and Whiskers is you can compare two different sets of people or conclusions, and it's very easy to see that the girls' data is much sort of closer together or much more tightly packed. You can see how much smaller the box in the Box and Whisker plot is for girls than for boys. You can see that the data for boys is much more spread out, and it comes through very clearly in the Box and Whisker plot. Now, let's do one more, because I do think that I want you to get a bit more practice. So I'm going to make it a bit easier. Here are the numbers. And what you are going to do for me is you are going to, oh, no, let's get rid of that. Sorry, I'm having a bit of a technical issue there. So here are your numbers written from smallest to biggest. I want you to find the 5-number summary for this data set, and then I want you to draw a Box and Whisker plot for this data set. Okay, over to you guys, and then I encourage questions as we go about doing this, if you're unsure of something. Oh, Kanisa, let's go to you. Yes. Can we unmute Kanisa? Hi.
Hi, sir.
How's it going? What can I do for you?
I wanted to ask if they said we must draw and label the box and whiskers, and then you find that for the boys, like the last situation, we had the Q3 and the maximum as 180 and 180. So what do we do? Do we label both at 180?
No, so it's a good question. So if you have the Q3 and the max value being the same, all that happens is you just have a box that literally stops and there's no whisker coming out. Now, you only label a Box and Whisker plot if you have no number line below it. And I have seen that sometimes, but most of the time, the correct way is to have a number line below your Box and Whisker plot, and you get your values by simply looking straight down from the Box and Whisker plot. So you don't have to draw the values on, you read them off by looking below onto the number line. Okay.
Okay, thanks.
Good question. Okay, 1, 2, 3, 4, 5, 6. So N is 15 for this data set. Which line are you working with? So you're working, this is the same set of data. This is just my scale to make life easier for you. So this is the data set here. This is the scale on which we're going to draw the Box and Whisker plot. Does that help with that question? Pleasure. I was trying to make your life easier, basically. So once you've got your 5-number summary, I want you to draw a box and whisker plot for me. Nice, Lisa Kanya. What are we gonna, once we've got our 5-number summary, then we have to begin to draw our box and whisker plot. And let me actually draw my box first, and then I'll do the whiskers afterwards. So 507, 515. And that shows me my interquartile range. And then that is the median, 510. But I'm not finished yet. I still need to do 2 more things. Okay, now I've drawn my box and whisker plot. Give me a thumbs up if you feel like you understand how I did my box and whisker plot. Give me a thumbs down if you feel unsure about something. I want to get a feel for the room. And I want to make some comments now about the box and whisker plot, but I want to make sure everyone is with me. Okay, so here is some important, I call this interpretation of the box and whisker plot. So listen carefully. If I look at my data, the top 25% is sitting over here. So that's the top 25% of data. The bottom 25% is sitting down here. What do you notice that is different about the two 25%? The bottom 25% is here. The top 25%, which goes from Q3 up to the max, what do you notice in terms of differences? What difference is there between the two? What do you notice if you look at it visually? So we can get to the skew to the right, but the top, I want to say the top 25% is more spread out than the bottom 25%. If I look at the bottom 25%, it feels like it's squished together, whereas the top 25% is more spread out. Also, if you look at the 25% above the median, so if we look at the 25% above the median and you compare it to the 25% below the median, you also see that the 25% of data above the median is more spread out than the 25% below. Now, the fancy word that we use for when one side is more spread out than the other is skewed. And so in this example, we say this data is skewed to the right, or we say it's positively skewed. So we can say positively skewed or skewed to the right. And all it really means is, on which side is the data, which side is it more spread out? If it's more spread out on the right-hand side, it's going to be positively skewed. And if it's more spread out on the left-hand side, it's going to be negatively skewed. Now, we're going to do a few more examples about that, but I just wanted to kind of bring it up for the first time now, because sometimes they ask you to interpret the data, and skewness is one of the things that we'll learn about. But I'll do more in the next lesson. Okay, let's do a couple of multiple choice questions to end today, just to finish things off. Answer this multiple choice question for me. What is the interquartile range for the information shown in the box and whisker plot here? what do we think the interquartile range is? The interquartile range is Q3 minus Q1, and Q3 is 9, Q1 is 4, so we get 5. And so the answer is B. Okay, well done. Then let's do this one. What is the range and interquartile range combination for this one? So the range is the difference between the biggest and the smallest. So the range is equal to, it looks to me like 18 minus 4, which is 14. And the IQR is going to be about 15.5 minus 5.5, which looks to me like 10. Is there an example that goes like that? Yes, it is B. Okay, everyone, you have done fantastically well. I'm so impressed by your performance today.